In this video we're continuing with the topic of vectors and we're going to look at dividing lines in a given ratio. Now we touched on this in the last lesson when we were asked to state the ratio in which a point divided a certain line, but this time we'll be starting with the ratio and then we'll be expected to find the point which is dividing the given line. So before we start looking at examples, we're just going to do a little bit of work around lines and ratios and what that means for the fractions as well. So say we have this line AC and AC is split by a point B. And I'm going to tell you that AB and BC are equal to each other. So those are the same length. Well, that means that AB over BC is equal to 1 over 1, which is 1. So that means that the ratio of AB to BC is 1 to 1. So we have a 1 to 1 ratio because AB and BC are equal to each other. Let's have a look at a different example. Say we've got the line DH. I'm going to split this into 4 different pieces. I've introduced the points E, F and G, which lie along the line DH. And you can see here that DE is equal to EF, which is equal to FG, which is equal to GH. So the line DH is split into 4 equal parts. So let's firstly look at the line DH and the ratio in which F splits the line DH. So we can firstly say that DF to FH is 2 to 2, or simplified is 1 to 1. And that means that the fraction DF over FH is 1. Let's look this time at how E, the point E, splits the line DH. And you can see there that the ratio of DE to EH is 1 to 3. And the fraction DE over EH is a third. And you can see there that what the third means is that this line DE is 1/3 of EH. You could fit 3 of the DEs into EH. And you can see that there because these are all equal. Right, let's look at G now and how it splits DH. So the ratio there is 3 to 1. And the fraction dg over gh is 3. We can see that dg is 3 times gh. Finally, let's look at df to fg this time. And that ratio is 2 to 1. So the fraction df over fg is equal to 2. And you can see there that df is double fg. So now we've done a wee bit more work around ratios and lines, let's have a look at an example of dividing lines in a given ratio. So P is the point -2, 4, -1, and R is the point 8, -1, 19. The point T divides PR in the ratio 2 to 3, and we want to find the coordinates of T. So let's firstly think about the scenario we've been given. We've got this line, PR, and we know that T divides PR in the ratio 2 to 3. So that means that PT to TR is equal to 2 to 3. Now visually that may look like this. As you can see, I've added in these extra points here in grey, and you can see that for every 2 equal parts along PT, I've got those 3 equal parts in TR. Now, expressing my ratio as a fraction, PT over TR is equal to 2/3. And multiplying throughout by 3 and multiplying throughout by TR tells me that 3 of vector PT is equal to 2 of vector TR. Now, vector PT, remember that's position vector T minus position vector P, and TR is position vector R minus position vector T. So I can express that as 3 times T minus P equals 2 times R minus T. Expanding my brackets gives me 3t minus 3p equals 2r minus 2t. And all the while here I want to remember that it's the coordinates of t I'm looking for. So really here I want t to be the subject of my formula. So I'm going to add my 2t to both sides and also add 3p to both sides. And that will enable me to get t to be the subject of the formula. Or rather 5t to be the subject of the formula. Now I need position vectors p and r so that I can substitute in here. So 5t is equal to 2 of 8 negative 1, 19, plus 3 of negative 2, 4, negative 1. That gives me 16, negative 2, 38, plus negative 6, 12, negative 3. 5t is equal to 10, 10, 35, and I can take a fifth of both sides, giving me t is equal to 2, 2, 7. And that's position vector t is equal to 2, 2, 7, which means the coordinates of point t is 2, 2, 7, which is my final answer here. So just now, it would be good if you pause the video before the screen goes blank, take down this example in your notes, and then try some practice on this from the assigned exercise for today.